Okay, this is lesson 80 for 7th grade, and today we're talking about transformations. And this is, like I told the students, we're going to be jumping around the book a little bit. This is a topic we'll see on the MCAs. We've talked about one type of transformation already, which is a translation, but we're going to talk about a couple other ones today. And we'll see an example of each, and this won't take very long today. Alright, our main transformations, as far as moving a shape goes, these are all movements. We have the names here too. We have reflection, which we associate with a flip, a translation, which we associate with a slide, and a rotation, which we associate with a turn. I will not be showing us an example of a rotation. That we can find in the book, but that's essentially when we just take a shape and we rotate it. Kind of like a doorknob or a car wheel, or something that rotates, something that spins. We can rotate it 360 degrees. We can rotate it more than 360 degrees if we want. Obviously though, any multiple of 360, we just end up back in the same spot that we started in. So we can go and turn it however many degrees we want to, even less than 360. We could turn it 90 degrees, we could turn it 42 degrees, doesn't matter. The thing is that we can rotate it however we want to. Look for an example in the book. This will come into play more so next year and in high school. But I do want us to know what it is. Translation we've worked with, that's when we take a figure and we slide it. We move it either up and down or left and right or both at the same time. So we'll see one of those. And again, and then also a reflection. The first thing we're going to see is a flip. So these are the first one we see, and we associate that with flipping. Okay, that's what they use. I like to use this instead. It's a mirror image of a figure that is reflected. So think about a mirror, and we're getting a mirror reflection. Okay, it says on a coordinate plane we might reflect shapes, and the lines represented by the x or y axis. So it's important to know when we reflect our shape or any sort of object, what line, or where is our line of symmetry, what are we going to reflect it across, alright? Translation we talked about, slides the figure to a new position without turning or flipping. So the orientation stays the same, we just move it to a new spot. And rotation, we'll turn the figure about a specified point called the center of rotation, and at the beginning of this lesson, they rotated a triangle 90 degrees, alright? So there's an example of that in there. Okay. The other thing, a dilation is a transformation that changes the size of a figure while preserving its shape. If we reduce or enlarge a figure, the resulting image is not congruent to the original figure, which means they're not equal or they're not exactly the same, but the image is similar to the original figure because the shape is the same. So here's our original triangle. This is a reduction, and reductions are more specifically called contractions. So this would be a contraction, and an enlargement would be a dilation. Alright. But like they said, all of these are definitely not congruent, but they are similar, which means all their angles are the same, they have the same shape, and all of their sides are proportional with one another. And we've talked about that before. Alright. Okay, so let's take a look at this here. The vertices of a triangle RST, or triangle RST, are located at 4, 3, 4, 1, and 1, 1. Draw triangle RST and its reflection in the x-axis. So we're reflecting it across the x-axis. First thing we always want to do with these transformation problems is graph whatever they give us. So we want to graph our triangle. R is at 4, 3, that's over 4. 1, 2, 3, 4, up 3, 1, 2, 3. This is R. S is at over 4, up 1. That's right here. And T is at over 1, up 1. There's our T. We connect our dots. And we get a shape just like that. Now we want to reflect it across the x-axis. So it'll be important to know which one the x-axis is. This is our Y. X is our horizontal axis. So what we're going to do is count how many units away each point is, or each vertice, is away from the x-axis. So for instance, t is 1 unit away. So what I'm going to do for its image is go 1 unit away in the other direction. Ooh, that marker is not very good. Let's try this one. So 1 unit away in the other direction. That one's not very good either. How about blue? Let's try blue. Just want you to be able to see it at home. Well, not the best, but I guess it'll work. Alright, so that's T prime is what I'm going to call that. T prime, that is just T as its reflected image. S is 1 unit away, so we go 1 unit away again. S prime. And R is 1, 2, 3 units away, so 1, 2, 3. And there's R prime. Connect. And we get our reflected image, okay? Now one thing that we should notice is if we were to fold across our line of symmetry, or the x-axis here, if we were to fold, these two shapes would match up perfectly, alright? And that's the thing that happens with reflection. So if it doesn't match up that way, you know you did something wrong. Alright, let's take a look at this rectangle and what we want to do with it. Rectangle ABCD has these vertices. We want to draw it and its image translated to the left 5 units and down 4 units. So first thing we're going to do is graph it. Over 4 up 3 for A, over 4 up 1 for B. Oops. There's A, here's B, and then C is 1, 1. And D is over 1 up 3. So here is our rectangle. We're going to translate it to the left 5 units and down 4 units. That means we take each point and translate it to the left 5 and down 4. I showed the students, they might have seen it like this on the MCAs. Alright, might have been like that, but that's okay. This just means we're going to go to the left 5 and down 4, which we could also take each point here, 4, 3, and put that in. If it's 4, 3 here, then over here it's going to be 4 minus 5, which is -1, and 3 minus 4, which is -1. So our reflected point should be at -1, -1. So let's see if that's true. 1, 2, 3, 4, 5. 1, 2, 3, 4. That is at -1, -1. So there's our A prime. B is going to be 2 down from that. Let's just check it. 1, 2, 3, 4, 5. 1, 2, 3, 4. Alright, so looks like everything's matching up. So now we know that D is 3 units away from A prime. And there we go. There is our new rectangle, or the reflected, not the reflected, the translated rectangle. That is the image there. Alright, one more to do. That is a dilation, which looks like this, okay? So we have another triangle, we're going to graph, and the dilation, we're going to dilate it with the center of dilation at the origin with a scale factor of 3. Most important part here, scale factor of 3. Alright, so first let's just graph our triangle. 1, 1, over 2 up 1, and over 1 up 2. Right there, so we've got Z, we've got Y, we've got X. So we have a small triangle there. And what we do is our scale factor, we just take that times our points. So 1, 1 times 3, 2, 1 times 3, and 1, 2 times 3. Alright, So here we go. 3 times 1 is 3, 3 times 1 is 3. Actually, here I'll use different color. We'll go blue again. So this will be 3, 3. 2 times 3 is 6. 1 times 3 is 3. And here we go, 3, 6. So our dilated image, over 3, up 3. Over 6, up 3. 3, 4, 5, 6. And then over 3, up 6. 1, 2, 3, 4, 5, 6. Z prime. And what we get is a triangle that has sides that are 3 times as long as the first triangle. Alright? And that's how we dilate a figure. Alright, that's all I have for today.